Everyone, how are you all? I hope you all are well. Welcome back. Today we are going to discuss a very important topic from grade 10, that is periodic properties. I have already made one video regarding the periodic properties where I have introduced the periodic properties. But today again I am going to discuss all the properties from the beginning. So let's start. Now before starting, I want to discuss something like periodic. When the term comes periodic means the things which is going to repeat after certain interval of time, like the sun rises, the sun set, and again on the other day the sun rises, and then the same pattern will be followed. So that thing is periodic. Okay, same periodic pattern is going to be found when we are going to discuss about the properties of elements. You have already learned about the periodic table in grade 9, where you have seen that the elements are arranged in the increasing order of atomic number in the two columns, that is, one is horizontal column, one is vertical column. Horizontal column known as periods, vertical column known as groups. So elements are arranged in those horizontal and vertical column, which together make a periodic table. So why we are saying it is a periodic table? Because we are going to discuss the properties of the elements which are periodic. So we are going to observe that how these properties are going to change and then again repeat. So it will be easy to us to remember that which are the elements having the similar properties and which are having different properties. So we are going to study now periodic properties and their variation, how it is going to vary when we are going to study about these properties in the groups and periods. So let's start. Before starting any periodic properties, you must understand the basic concept. If you understand one of the periodic property properly, you can understand rest very easily. So let's see. Now the first thing is, the first property which we are going to discuss today is nuclear charge. Now this is very important thing. If you understand nuclear charge, then you can understand the properties variation. Nuclear charge is also known as nuclear force. So nuclear charge and nuclear force is the same thing. Okay. Now what is this nuclear charge? Suppose we consider an atom, like this is an atom. Okay. We have considered an atom which is of spherical shape like this. Okay. Now in an atom, you all know there will be a nucleus present in the center of an atom. So suppose this is our nucleus. Okay, this is our nucleus which is present in the center of an atom. Now we all know that nucleus is having two subatomic particles. One is proton and other is neutron. Okay, these are the two subatomic particles which are present in a nucleus. One more thing, proton is positively charged, neutron will be having no charge, but their mass is quite heavy. That's why the nucleus is quite heavy as compared to the rest part of the atom. Now around the nucleus, the shells are there. Okay, like k element shells, you already know that. So in those shells the electrons are present and the electrons are moving around the nucleus of an atom. Electrons are very light as compared to the proton, that is having a mass around 1/1837 times mass of proton, and they are negatively charged particles. Now we all know, if suppose a positive charge is there and negative charge is there, then there will be one thing exists between them, that is the attractive force, because opposite charges will attract each other. Very simple. Same is going to happen here, like proton is positively charged while electron is negatively charged. So proton is positive, electron is negative, so it results in the formation of what? A attractive force between them. Attractive force between what? Electron and proton. Okay. Now the problem is that electrons are quite light as compared to proton. So proton is going to pull the electron toward it. So it means the nucleus of an atom is going to exert a force, that is attractive force, on electron. So electrons are going to be pulled toward the nucleus of an atom, and hence this attractive force between the proton and electron is known as nuclear force. Okay, because nucleus is because the electrons are pulled toward the nucleus due to the heavy size of the nucleus, it is going to pull the electrons toward it. So it means the force is named after the nucleus, so it is known as nuclear force or nuclear charge, you can say. Okay, now it is going to play a very important role in the periodic properties. So first of all, we have to see that how this nuclear charge is going to vary. That is how the variation is there in the nuclear charge. Whenever we are going to study about the variation in the periodic table, we are going to study the variation in two forms, that is left to right of the periodic table, which is known as across the period, and top to bottom of the group, that is within a group. Okay. So first we are going to discuss now the variation of nuclear charge. Variation of nuclear charge. Now variation of nuclear charge, first we are going to discuss across the period. Okay, first we are going to see that how the nuclear charge is going to vary across the period. Okay, now when you see across the period, now what is going to happen here? You know, suppose I am going to take one example. Lithium element is there, then after the lithium, which element is there? Because lithium is present in first group. Then after lithium, the beryllium is there, then boron is there, then carbon is there, then nitrogen is there, then oxygen is there, then fluorine is there, and then neon is there. That is, they are like this according to the atomic number. What is the atomic number of lithium? That is going to be 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Now when you know the atomic number of any element, you can easily write their electronic configuration. So I am going to write the electronic configuration of these elements here. You can see it. Like lithium will be having the electronic configuration 2, 1. Okay. Then after the lithium, the other element which is there, that is beryllium will be there. So its configuration is 2, 2. After beryllium, boron is there, that is 2, 3. Then after boron, that carbon is there, that is 2, 4. Then nitrogen 2, 5. Then 2, 6 oxygen. Then 2, 7 fluorine. And then 2, 8 neon. So like that the electronic configuration of the element will be there. Now what this electronic configuration says, that there are 2 shells. Every element here are having 2 shells. Okay. So what we see, that the number of shells when we are moving across is remaining same. Okay, but electrons are increasing by number 1, like 1, 2, 3, 4, 5, 6, 7. So what it is going to happen now, electrons are going to increase in this shell. So it means the protons are also going to increase in the same manner in the nucleus of an atom. Okay, but the number of shells are same. So in this case, what is going to happen, when the protons are also increasing and the electrons are also increasing and the number of shells is remaining same, the attractive force between the nucleus and the outermost shell electron, which is also known as valence shell, is going to increase. Okay. So it means if lithium will be having some value of the nuclear force, then after lithium the beryllium will be having more nuclear force, then the boron, carbon, nitrogen are going to experience more of the nuclear force because the number of protons and electrons are increasing, but the number of shells is remaining same. So what does it shows? It shows that the nuclear force is going to increase when we move across the period. Okay, so when we move across the period, the nuclear force is going to increase. Okay, so whenever we are moving across the period, that is left to right, the nuclear force is going to increase. So that is how the nuclear force or nuclear charge is going to vary across the period. Now we move to the other part, that is the second variation, that is the variation down the group. When we say variation down the group, it means that within the same group we are talking about. How the elements nuclear charge is going to vary in the same group we are talking about. Okay, now I am going to explain it with example. Like lithium, it is present in the first group with atomic number 3, configuration 2,1. Then after lithium, the next element is sodium in the same group I am talking about. Configuration is 2,8,1. After sodium, potassium is there, that is 2,8,8,1. Sorry, yeah, 2,8,8,1 because the atomic number is 19. Now in grade 10, basically you have to study the periodic properties till the argon on calcium only. So we are going to study till potassium here. Now lithium, sodium and potassium, these are the elements present in the first group. Now what you will observe, if you can see the outermost shell electron, that is 1, 1, 1, that is same, but the number of valence, number of the shells in each successive element are increasing by 1. Like in the case of lithium there are only 2 shells, in case of sodium there are 3 shells, in case of potassium there are 4 shells. So the number of shells is increasing. Now what it will do? It means, like suppose this is a distance between the nucleus and the outermost shell electron here. Okay, I will make one more shell so that the distance will be like this. Okay, now in this case the number of shell are increases by 1, so the distance between the nucleus and the outermost shell is also increasing. Now in case of potassium, the number of shells are going to be 4. It means the distance between the nucleus and the outermost shell is again increases further. Okay, so when the distance between the nucleus and the outermost shell is going to increase, the nuclear force is going to be weak for the valence shell electrons. Okay, it's just like simple thing, like if you are having a magnet, it's an iron piece, iron piece near to the magnet, the attractive force between the magnet and iron is going to be more. But if I will take the iron piece away from the magnet, the magnetic force is going to get weaker and weaker. Same is going to happen when the electrons, that is outermost shell electron I am talking about, is moving away from the nucleus, that is the distance is increasing, the force is going to get weaker and weaker. It means what is going to happen? The nuclear charge is going to decrease when we move down the group, that is from top to bottom within the same group. Okay, so you have learned that how the nuclear charge is going to vary across the period and down the group. Now you have to remember this, because when we are going to learn about the other properties, this is going to be an important factor, because I will be using that factor to explain that. Okay, so now we are going to study about the next property, that is atomic size. We are going to discuss the second property, periodic property, that is atomic size. So let's start. So our next property is there, the second one, that is atomic size. When we say atomic size, it means the size of an atom. Okay, So let's quickly know that what is atomic size. Atomic size is simple. Suppose this is the atom and this is the nucleus of an atom. So basically the distance between the nucleus, okay, distance between the nucleus and the valence shell. So basically the distance between nucleus and valence shell. So that distance between the nucleus and the valence shell is known as atomic size, atomic radii also we used to say. So now we are going to see that how this atomic size or atomic radii is going to vary down the group and across the period. So first we see variation across, okay. So how this property is going to vary across the period. So again we are going to use the example of the second period, that is lithium, and after that lithium you all know the next element is beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Now we know we have done that when we move across the period, the number of the shell is going to be same, but the number of electrons are going to be increased by 1, which increases the nuclear charge. So now when we are moving across the period, that is from left to right of the periodic table, then the nuclear force is continuously increasing. So if nuclear force is continuously increasing, means the electrons are going to be pulled more toward the nucleus of an atom as we move across the period. It means if the lithium size is this much, then beryllium will be having lower than that, boron will be having more, less, and so on. The size is going to decrease because valence shell is pulled more toward the nucleus of an atom due to greater nuclear charge, okay. So it means when we move across the period, the atomic size is going to decrease, okay. So the atomic size is going to decrease because of the increase in nuclear charge. So we are going to use that property here. Because of the increase in nuclear charge, the atomic size is going to decrease from left to right of the periodic table, okay. So lithium will be having here greater atomic size, while neon will be having the smaller atomic size, okay, understood. Now so the atomic size is going to decrease when we move the left to right of the periodic table. That is how the atomic size is going to vary across the period. Now the second type is there, that is second variation I am talking about, that is variation down the group. When we say variation down the group, again we are going to use the property of the nuclear charge, that how the nuclear charge is going to vary down the group. Now we know when we move from lithium to sodium to potassium, the number of shells are increasing, which automatically decreasing the nuclear charge. So when the nuclear force is less on the outermost shell electron, it means the electrons will be going to be away from the nucleus. It means the size of the atom is going to increase, okay. Obviously because the number of shells are also increasing, so the distance between the nucleus and the outermost shell is already increasing, but also the nuclear force is less on the outermost shell electron. So it means the atomic size is going to increase down the group. So when we move from lithium to sodium to potassium, okay, suppose lithium will be having this much size, then sodium will be having greater than that, and then potassium will be having more size than that. So it means the atomic size is going to increase when we move down the group because of decrease in nuclear charge. So you have seen that we are using that property here, okay. So if you understand that property, you can easily write the reason, because suppose you are getting the question and they are asking that what is the reason why the atomic size of this element is greater than that, then you can give this reason, that because of the increase in nuclear charge or decrease in nuclear charge, that depend upon where they are asking, maybe across the period or maybe down the group. Suppose they ask you to compare the lithium and barium, then you can say that barium will be having smaller atomic size than lithium because of the greater nuclear charge, while when they are asking the comparison between lithium and sodium, then you can say sodium will be having greater atomic size because of the less nuclear charge. Okay, so that is how this property vary. Now we move to our third property, that is the third periodic property we are going to discuss. So our third periodic property is ionization potential. Ionization potential. Okay, so how this ionization potential is going to vary across the period and down the group, that we are going to discuss later. But first you must know that what is the meaning of this ionization potential. Ionization potential is also known as the ionization energy. Okay, now what is the meaning of that? In short, we can use as I dot E for ionization energy or I dot P for ionization potential. Now ionization potential or ionization energy means that is the amount of energy which is required to overcome from the nuclear force. Now you know that metals, like suppose example, metals used to lose electron, as you have learned in chemical bonding also, that metals used to lose electron. Okay, so how can they lose electron? Because nucleus is going to exert the force on the outermost shell electron. Suppose I am giving you one example. Suppose this is the sodium metal. Okay, now in this sodium metal, suppose this is the electron which is present there. Now sodium tends to lose this electron. Okay, but how can the sodium lose this electron when nuclear force is exerted on this electron? Already a kind of a force is exerted, that is attractive force is exerted on the electrons, outermost shell electrons. Then how this electron is going to move away from the sodium metal? So in this case, the ionization potential plays an important role. In such case, electrons will acquire amount of energy which is required to overcome this attractive force. When electron will get that much amount of energy which is required to overcome this attractive force, that is nuclear force, then it will come out of the atom. So that amount of energy which is required by an electron to come out of the nucleus of an atom is known as ionization potential or ionization energy. When it comes to definition, it is like the amount of energy required to remove the electron from the isolated gaseous atom. Now they use one word, that is isolated gaseous atom. So when you are writing the definition exactly, you have to use this. In simple word, it's the energy required to overcome the nuclear force by an electron. Okay, but the amount of energy required by an electron from isolated gaseous atom is known as the ionization potential or ionization energy. Now what is the meaning of this isolated gaseous atom? When an electron is going to be removed from any atom, then in such case the atom is required to be in the gaseous form. Okay, it is required to be converted into the atomic form, gaseous atomic form, and then only it is going to lose electron. Okay, so it means the amount of energy required by an electron to be removed from the isolated gaseous atom is known as ionization potential or ionization energy. Okay, so that is the meaning of ionization energy or ionization potential. Now we are going to see that how it is going to vary across the period and down the group. So first is variation across the period. Variation across the period. Now when we see variation across the period, how the variation is there, it is again depending upon the nuclear force. As you can see that it is the energy required to overcome the nuclear force. So when we are moving left to right of the periodic table, just an example, that is lithium to neon. In such case, we know that nuclear force is going to increase. So when nuclear force is going to increase, it means the requirement of energy for an electron is also going to be increased, because electron will require more energy to come out as the nuclear force is increasing. Okay, so it means the ionization potential is also going to increase when we move left to right in a periodic table. Understood? It's very simple, directly depending upon the nuclear force. Like suppose lithium is there and its electrons, it's just like that force is like it's tied with a thread, or when we are moving toward the right, it is tied with a strong rope. So when a strong rope is there, to break that rope, more energy is required. Same is here. Okay, so ionization potential is going to increase as we move left to right to the periodic table. Now we see the another variation, that is the variation down the group. Now when we see variation down the group, again it is depending upon the nuclear force. Okay, so when we move from T to B, I am writing T to B means top to bottom. That is in case of the first group element, lithium to potassium. Nuclear force is getting weak when we move down the group. So the requirement of energy for an electron is also going to be reduced to overcome that nuclear force. Hence, the ionization energy or ionization potential is going to decrease as we move top to bottom of the group. Okay, so as you can see, it is directly depending upon the nuclear force. Understood? Now we are going to discuss the ionization next periodic property, that is going to be the electron affinity. Now we are going to discuss the next periodic property, that is electron affinity. So now we are going to see what is the electron affinity. Electron affinity, actually it's like opposite to ionization potentials. Now ionization potential is related to those elements which are going to lose the electron. Okay, and same is with the electron affinity, which is related to the opposite thing, the elements which are going to gain electron, like non-metals. Non-metal tends to gain electron easily. Okay, now what is this electron affinity? Electron affinity means the amount of energy which is going to be released. Okay, it's the amount of energy which is going to be released when an electron is added to isolated gaseous atom. Okay, so it is the amount of energy released when an electron is added to the isolated gaseous atom. Okay, means when electron is going to be gained by any atom, then whatever the amount of energy is released at that time, that is known as electron affinity. Okay, it is known as electron affinity. So basically, as it's a energy released, so we measured it as the negative form, negative as a sign convention, because it's a energy release. So when any atom is going to release more energy, it means it is going to have higher value of electron affinity. So we used to say the element will be having more negative or less negative. The one which is having more negative means having more electron affinity. The one which is having less negative means having less value of electron affinity. Why we are using negative sign convention? Because it's an energy release. So it's an exothermic process, and for an exothermic process we use a negative sign convention. Okay, so more negative means having greater electron affinity, less means having less electron affinity. So let's see how this property is going to vary across the period and down the group. Now when you see left to right of the periodic table, that is the example, again we are using lithium to neon. We see that elements nuclear force is going to get increase. So when the nuclear force is going to get increased from left to right of the periodic table, it is easy to accept electron rather than lose electron, because nuclear force is increasing, so atom cannot lose electron easily, but it can accept electron easily. So when it can accept electron easily, it means it will be having greater value of electron affinity. The value of electron affinity is going to be more and more. Hence, the electron affinity is going to increase because of the increase in nuclear charge from left to right of the periodic table, okay, or we say it become more and more negative as we move left to right of the periodic table. Understood? Now we come to the variation down the group. Always, whatever the variation is there in the across period, the property will be having opposite to that in the down the group. So when we move from top to bottom, okay, of the group, that is the example we are using lithium to potassium, like we are using only 3 elements in this group. Rubidium, cesium, francium we are not using. So the electron, when we move down the group, you know that nuclear force is going to get decrease. Nuclear force is getting decrease as we are moving down the group, top to bottom of a group. So when nuclear force is decreasing, it means it's very easy to lose electron, or it is easy to release electron as compared to accept electron. So it means if it is not easy to accept electrons, the electron affinity is going to be less and less. So the electron affinity is going to decrease, okay, when we move from top to bottom of a group, or we can say it become less negative, okay. So electron affinity is going to be less negative. One more thing, students, electron affinity can also be known as electron gain enthalpy, because it's an energy related to the gaining of electron, okay. So it can be also known as electron gain enthalpy. I am writing it here, electron gain enthalpy. Sometime the other name can be used and you will be confused, so it will be also known as electron gain enthalpy, okay. So it become less negative as we move down the group. Now we move to the next property, that is non-metallic properties of the elements or electronegativity. Now what is the meaning of this electronegativity? Electronegativity means the tendency of any atom to attract electron, tendency of atom to attract electron, okay. So if any atom is easily accepting electron or attracting electron toward it, it means they are said to be more electronegative, okay, or we can say they will be non-metal. So basically the non-metallic property or electronegative property is relatively similar, okay. So we are going to see how it is going to vary across the period. If we say lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine, okay, what we see, lithium is metal, okay, and carbon onwards till fluorine all are non-metals. Why? Because nuclear force is increasing, okay. As we move across the period, nuclear force is increasing. Also we can use this example, electron affinity is also increasing as we are moving across the period. It means tendency to accept electron is more when we are moving left to right of the periodic table. So it means the electronegativity or non-metallic character is going to increase when we move left to right of the periodic table. Understood? Next is variation down the group. Again, it's going to be opposite to that. So if we are taking the example of first group, lithium, sodium, potassium, then the electron affinity is going to be less negative or getting less when we are moving down the group. Nuclear force also getting less down the group. So it is easy to lose electron as compared to accepting electron. So it means the electronegative character is going to decrease as we move top to bottom of a group. Even in some of the groups which are non-metallic group basically, but the element which is found in the bottom may have metallic character. Sometimes it happens. Because down the group the metallic character is going to increase, non-metallic character is going to decrease, or electronegativity is going to decrease. Okay. So that is how it varies. We have one more property to discuss, like metallic character, but I am not discussing. Why? Because whatever you are going to study about non-metallic property, opposite to that is going to happen in metallic. If on the left side you are finding metal, so it means on the right side here you are finding non-metals. So non-metallic character is increasing. So when non-metallic character is increasing, so obviously metallic character is decreasing. Same is here. When we are moving top to bottom, the metallic character is going to increase as non-metallic character is decreasing. So it is going to be relatively similar. So no need to discuss that. So that is about some of the periodic properties which is required to be discussed. Okay. So I have discussed it. Just go through it. Maybe in the coming videos we'll be discussing some of the questions related to that, and maybe other properties if it is required. Okay. So that's all for today. So like my channel, subscribe my channel, don't forget to press the bell icon, and please support me, share as much as you can. Thank you students, see you in the next video.